Hello, my name is Benedict Jesch. I'm an aerodynamicist here at WUT Racing, which is a Formula Student team at the Warsaw University of Technology. Formula Student is a competition organized by the Society of Automotive Engineers, where different engineering teams from different universities all around the world can test their skills in constructing a race car. Our work in designing the aerodynamics of the car mostly revolves around designing and testing different geometries in CAD software and also running CFD simulations to confirm that our ideas are working. Our aerodynamic department runs upwards of 30 cases a week. So, as each case takes around 6 to 8 hours to calculate, we are highly limited by time when calculating. Currently, we are also using mostly our own equipment, our own computers to calculate the CFD cases. We have access to HPC platform provided by our university. However, we are only allowed to use a limited number of nodes and only CPU computing. While working with CodeZero, we've managed to get access to a platform with GPU computing enabled, which allowed us to run our simulations around 3 times faster than on our current HPC platform, which in essence allows us to run twice as many simulations in a day, which highly accelerates our design process. Using all of the computing power provided to us by CodeZero, we can reach a new high in our simulations and rise to the highest level of our capabilities. CodeZero's immersion cooling technology allows us to not worry about damaging our planet when we're doing our work. We can also drive towards the environmental factors that the motorsport world is moving towards lately. Our experience working with CodeZero so far has been wonderful. We have a lot of interesting things coming up and a lot of very complicated and advanced projects that are soon to come. We are excited to continue our collaboration, and we are hoping that it can be really fruitful and eventful.
We've been able to complete this project with the help and collaboration of the aerodynamics team at University Warsaw Racing, and we've been able to deliver affordable and sustainable high-performance compute in the form of computational fluid dynamics running in immersion. We've done this using a single virtual machine with 64 cores, 128 gigabytes of RAM, and a single NVIDIA A40 GPU, again, all running in immersion. We've been able to do this because we understand design and architecture, and we've ensured that the virtual machine is only pulling the resource from a single host rather than pulling it cluster-wide. That means that we can deliver maximum performance and speed through optimization and efficiency, and deliver a platform that's far cheaper, more cost-effective, and more sustainable than traditional HPC platforms. Everything that we've done in this project has been about delivering high-performance compute on this platform and showcasing that we can reduce the TCO for customers, we can deliver more increased sustainability, and we can ultimately drive innovation and foster growth by removing complexity and barriers for 99% of businesses. We ran a 20 million cell mesh for the exercise, and we were able to performance benchmark that, capturing CPU usage, memory usage, GPU usage, but including things like GPU temperature. And to give you an idea, when we were running this simulation on the GPU, we were able to see that the GPU temperature was just 45 degrees running in immersion. That's running 96%, 100% of the time of the 48 gig memory. So the platform that we've been able to deliver in collaboration with our ecosystem partners has allowed us to deliver maximum performance for Warsaw University Racing And our platform has delivered their CFD simulation 3 times quicker using the GPU in immersion than their entire HPC cluster. I want to say a huge shout out to our ecosystem partners, Green Revolution Cooling, BP Castrol, Centre Square, Unicom, Engineering, and lastly, a special thank you to CADFEM UK. CADFEM UK helped us get the Enterprise Fluent license with HPC packs. They helped me personally deploy that license, and they also helped troubleshoot any issues that we had when running the simulations on GPU. The final stage for this project will be moving towards using the entire cluster, which is 3 Dell R750s, populated. Each node has 2 Intel Platinum 8352Ys, 256 gigs of RAM, 20 terabytes of NVMe storage, and 2 NVIDIA A40s. And our goal is to run 140 million cell mesh for CFD simulations, which is close to what a Formula One racing team would run in their own environment.
GRC are really proud to be part of an ecosystem delivering computational fluid dynamics in immersion via our partnership with CodeZero into Warsaw University Racing. Today we're here at Centre Square, where we have our GRC micro rack running the servers that we used for the CFD process.
Castrol is excited to be working with GRC and CodeZero on this exciting project where they are taking high-performance computing workloads, specifically in computational fluid dynamics, where they are working with the University of Warsaw Racing team to figure out better ways of improving racing performance. And as Castrol, we're really proud to be presenting our immersion cooled fluid solution to help power these IT workloads where performance and efficiency are very key. And I'm looking forward to see how we can push the boundaries of computing performance together.
At CADFEM, we pride ourselves on delivering expert simulation solutions to help drive innovation. Recently, we partnered with CodeZero to help them perform a large-scale CFD simulation of a Formula student race car using Ansys Fluent, installed on CodeZero's cutting-edge immersion GPU platform. When Andy at CodeZero first approached us with this exciting project, we were certainly up for the challenge and provided CodeZero with an evaluation license of the Ansys Fluent product. To maximize hardware and software performance, we worked closely with CodeZero to configure their virtual machine and the Fluent solver as they scaled up the complexity of the CFD simulation. We also provided guidance on leveraging the Fluent solver on NVIDIA GPUs. This work ultimately led to significant race car performance advantages for the Formula student team. With CADFEM's expertise, CodeZero is now equipped to push boundaries,